And so when it comes down to calculating the cost, don't rush to the cost right away. First, figure out how many loads or how many sheets of plywood or how many would I need to buy to complete this project, which means first you need to figure out how much are you covering, what's the area you're covering, or what's the volume that needs to be filled, right? So we're gonna go here, have your calculators ready to go, right? So there's a construction crew that is pouring concrete into cylindrical pillars, right? So those pillars have a volume of 0.26 cubic yards. The crew ordered a load of 5 cubic meters of concrete, and it costs $850. Okay. Calculate, right? You want the total cost of concrete for 100 pillars that need to be poured. And again, no partial loads can be purchased. Can I make actually when I read this, the crew is able to order loads of 5 cubic meter. How's that? The crew is able to order, right? The crew is able to order loads of 5 cubic meters. It's a bit blurry, right? Let me focus here. So make that addition there. Wording does matter, right? So we need to make sure we have that adjusted. So we're going to go, first of all, concrete needed, concrete required, right, would be 100 pillars times 0.26 cubic yards, right? So every single one of them needs this much. So if you get 100, obviously you need to order enough for that. So 100 times that would just be 26 cubic yards. Okay, so that's important. So I'm going to underline that. And then you need to figure out how many loads, right? Loads required. Because in this case, you can order 5 cubic meters at a time. Okay, so you're going to have to figure out how many loads are required. So I'm going to say that one load has 5 cubic meters. So I'm not rushing to my cost just yet. I need to figure out, hey, I can't use partial, so I have to figure out how many loads. So X number of loads will get me the 26, oops, I skipped this step. But I kind of like that this happens to me too. What's the problem? Yeah. Yes, you're in meter. I'm right. Yards, meters. Right. So no problem. That's why I have lots of room here. So I'm just going to go ahead and convert. So from here, I'm just going to go arrow out. And I'm just going to go 26 cubic yards. I know that you might have done it differently. Some of you would probably convert the cubic meters to cubic yards. Not a problem. I'm fine with that. Okay, so it might be frustrating to you because I did it a different way. You're not wrong. Okay, but I know that yards and meters, right? 1 yard. I always try to memorize these, and I have to be careful. So you can't just use that, right? Remember the cube? So you got to cube the whole thing. Remember that for grade 12 applied. It's going to be the first thing in grade 12 applied. I mean, depends on who. I mean, Ms. Yasek and me, if we teach it, that's the first thing we do as well. This kind of stuff, but we take it a little bit further. And so let's figure that out. So I allow you to just do this, right? I take my 26 and then I multiply it by 0.9144, but be careful, you need to cube it. So use the power button, right? That little hat to the power of 3. And you got to be very careful. And then I just hit enter. So that is 19.878. And now I am in cubic meters. So in a sense, this cubic yard here canceled out with that cubic yard, right? So now we're talking. So we can go back to, if I go arrow, I'm just going to get rid of all this. I won't do that. But I will highlight it. How's that? 19.878 ... cubic meters. Told you I like highlighters. Right? Kind of stands out. Yeah.
What number is that?
That's X number of loads. Yeah.
No, the other one.
This one?
Oh, that's one.
This one? That's 1. Yeah. It's a weird looking one. The weird one. Got it? Got it. Anyways, that's why they put me in the cabin. All the weird teachers, they put them in the cabin. Okay. So times divide. 19.878 ... That just means I'm using all the decimals. I'm using my calculator once I compute that. Times 1 divided by 5. So I'm going to go copy that and then just divide it by 5. So that's 3.97. That keeps going. What are we in? What are we finding? Finding number of loads. So we can't buy partial, right? So this is where that comes in. That statement comes in right here. I need to buy how many? I need to buy 4. Okay. Also important. So this technically, instead of 3 steps, it's actually 4 steps because of the extra conversion here. But now I can do the cost. So conversion is just a fact. If you need to do it, you do it, right? Cost would just be 4 times 850. That's it. $3,400 to do that. So if you haven't gotten your highlighters yet, get at least 4 different colors. Trust me, as we go down the units, it will be very handy to see. It's like, okay, this is connected here. This is where I got that from. All those things. We're good? So when it's cost, make sure you think it through. How much do I need? Okay, got it. So how many units am I going to have to buy, right? It could be sheets, it could be loads, it could be cans, whatever. And then cost. And conversions will most likely be required along the way, okay? We should all get the same though, right? We should all get the same answer. So these extra pages, just leave them blank for now. And let's go to scale diagrams. This is on page 10, okay? Scale diagrams, I will put in brackets, okay? Scale and scale factor. I want to add that. The textbook calls this section scale diagrams, but really the main focus is going to be on scales and scale factors. Okay? So a scale diagram, a diagram in which measurements are proportionally reduced or enlarged, right? Measurements by a constant factor from the actual or the original object. Right? Notice the words actual and original, right? It's gonna come back. A scale is a ratio of measurement of a scale diagram to the corresponding measurement on the original actual object. Okay. Scales can be reduced just like fractions. So let's highlight that. Different units are okay, but no decimals. Okay. That's the one thing you need to remember about scales. Scale, the most common one we know of is maps, right? Maps are drawn to scale, right? So you take the actual area, right, that you're looking at, and you're shrinking it down to a smaller, your screen, your cell phone screen, or whatever. And it's the important thing is that everything is scaled up to the same amount, right? You can't just shrink the width in half and the length in thirds. We do everything by the same amount, so it's a constant. A scale factor, the letter K is associated with scale factor, which is going to be the most popular thing that we're going to deal with. Similar to scale, but it's expressed as a fraction, decimal, or percent, and it has no units. Okay, a scale factor doesn't have any units associated with it. They cancel out. Okay. So I want you to see them side by side because they are related. The scale and scale factor, obviously the word scale appears in both of them, so they are related, but there are some differences there that you need to make sure you account for. So a scale is written like this. We usually have diagram, right? There's the measurement of the diagram compared to the actual. Okay, so sometimes we'll refer to the diagram and actual, and then at other times we will, instead of using diagram actual, we'll use new and original. Okay, so new and original is when making copies. Okay, when you're making a copy of something, so let's say a manufacturer, like an Amazon seller, is selling an object, and they need boxes that are a certain size, and now you're saying, hey, we need a box that is twice as big, right? You're making a copy of that original. And diagram and actual, obviously, when you're looking at pictures, right? When you're dealing with pictures, blueprints, etc., then we would rather use diagram actual. Okay? And then scale factor, we most likely will be writing it as like this. Watch. The scale factor is found by taking the diagram, it will be a number down the road, divided by actual. Okay. Or we will only be using one of these versions depending on the situation. Okay. We will be taking the value of the new, so it could be the new length, divided by the original length. And there are no units. No units, I'm saying that because it's very important. Convert as needed, right? Convert as needed. So bullet there, and you'll see what I mean by that. We'll have to do some converting at times to cancel out the units. All right, this part right here, this box, it's boxed in, so it's important. Just try to shrink it down a little bit, right, when you're transferring it to your study sheet. But it is important. It's there for a reason. Scale factor. When you're dealing with scale factors, it's easy to tell. Remember, scale factors affect the actual or original. which results in the diagram or the nu, right? So when you look at a scale or scale factor, it will tell us what happened to the actual or the original. Okay. So if the value of k is less than 1, so examples would be 0.2, 2 divided by 3, 2 over 3, anything like that, 65% is less than 1. Would you agree with that? 65% is less than 1? Because it's what is it turned into a decimal? When you write 65%, it is really 0.65. So I will say this. I will add that k is less than 100%. If you want to write that down, if that helps you, write it there. Okay. If k is equal to 1, it's the identical, right? Identical copy. Therefore, do you know this symbol? Therefore, the 3 dots like that. That stands for therefore in math. No change. Okay, I'm going to kind of block this off like this, like that. And then if k is greater than 1, you can also say k is going to be greater than 100%. You're saying the same thing, by the way, right? So if you're at 1.2, or if you're at 5 over 4, or if you're at 120%, any one of those scale factors represents an enlargement of the original. So let's write here on the side enlargement of original. Technically slash actual, but I'm just going to do it that way. So we can put this in kind of like a little cloud, right? If you see that k is bigger than 1, right, whatever, if that's the case, then you know that the original has been increased, right, in size. If it's less than 1, then it's a reduction. Oops, sorry, can't see that, can you? There, so it's reduction less than 1, and I think that should make sense to you, right? That that's the case. Maybe I should. This projector doesn't like yellow as the background, so it's kind of going crazy here. Anyways, let's start to think about this a little bit. I want you to start thinking about it. If the scale factor is 65%, right? So that tells us that the original has been reduced. By how much has it been reduced? Because remember, the actual is 35%. Yeah. The original is always the 100%, right? So if you have anything less than that, so let's say your scale factor is 80%, it has been reduced by 20%. So sometimes students are like, oh, obviously 65% has been reduced by 65%. It's like, no. 100% is the start. How much has it been reduced by? Okay, so I want you to start thinking about it. And so similarly, when you have a scale factor of 120%, it has been increased by 20%. All right, so think about it that way. You're the first group that gets this booklet, okay? So a lot less writing, but it differs from my original, so I have to sometimes I kind of forget to like add stuff there. So I hope you enjoy the booklet. Okay, given a scale, so next page, page 11, given a scale of 1 centimeter to 50 meters, state the scale factor used. So we're gonna, at the top here is converting a scale to scale factor. Because when we do math, quite often we just like to take it to the scale factor because there are no units attached. We're good to go. Okay. So this is a scale. Scale has the colon in between, right? Separating. So we know right off the bat, you should know. And you're like, Mr. Dirksen, which one should I use in this case? It doesn't really matter. Maybe we could use this or this. This is just important to have the terms in the right place when you're doing a word problem. And I'll show you that in a bit. But let's just stick with one of them. We know that this would be representing the diagram. And this is what it's in reality, right? The actual. So we know that every centimeter on our piece of paper represents 50 meters in real life and on the actual landscape, okay? So that shouldn't surprise you. But to convert that to a scale factor, we want it like this. K is equal to, just remember that the first number always goes in the numerator and the second number always goes in the denominator, just like that, okay? What's the problem with the scale factor right now? Different units. It has units. That's just it having units is a problem to us. So we just need to make the appropriate conversions, right? So we know that 1 centimeter has, can we just do this kind of on the side, or do you need me to, I'll do that over here. 50 meters, right? 1 meter has 100 centimeters. And you're like, why didn't you convert the centimeters to meters, Mr. Erickson? It's fine, but I usually take the bigger unit and convert it to the smaller one. That's just, it tends to be less, it's not as ugly, right? Sorry there. So I'm doing the conversion up here. Cancel, cancel. So it's 50 times 100. No surprises. So it's 5,000 centimeters. Is my camera? I need to zoom out a bit. Sorry, guys. Sorry. There. 5,000 is right there. I'm going to use my orange, right, to make that 5,000 appear down here. Oh, centimeters. Sorry. But that's, I needed to do this on the side, right? And now we get to cancel out the centimeters. So we're left to 1 over 5,000. And there you're technically done. This is correct. But if I ask you to state it in the 3 formats, right? K is equal to 1 over 5,000. Or turn that into a decimal. You know how to do that? Yes, you do, right? Just 1 divided by 5,000. That's the problem with these calculators. It's the one issue I have with it. It goes to scientific notation. Did we have that problem already before? I forget if it was this class or the grade 12 applied class. And this is my way around it. Obviously, if you're in chemistry or physics, bio, you do this all the time. But what I do is I just go plus 1. I just add 1 to this answer. But you have to ignore the 1, all right? But that tells me that my answer is 0.0002. Got it? The plus 1 is just to get rid of that scientific notation. And I haven't figured out a way to make this calculator stop doing that. If you figure it out, please let me know. And then how do we get that to a percent? We gotta take that 0.0002 and just multiply it by 100, which you already know as well, but that's 0.02%, right? So we just took this, multiply that by 100 to get that. Okay. I showed you the trick, but I think you need to know scientific notation anyway. So if you get that ever down the road and you're like, what? 2 e to the negative 4. Sorry, it actually has it all in one line. You know what that is, right? It is saying 2 times 10 to the negative 4. Does that sound familiar? And what is that? Take this number. If it's a negative, that means you're shifting left. So the decimal starts here. You're going 1, 2, 3, 4 decimal places. 4 decimal places. And then you fill these values you've created with zeros. Right? And then obviously a 0 in front. So this is what it is. That's that number. So the little cheat there that I showed you is just to make it a little quicker. But I think you need to know this. This is just an aside, right? Does that make sense? You've seen scientific notation grade 9. I'm pretty sure. I mean, COVID, who knows what happened, right? Did you even learn anything? Yeah, you did? I'm just kidding. It was a nightmare for us, trust me. And for you. Oof. Must have been tough for you guys. Still recovering. Okay, next. Determine, right? The scale factor used, sorry, not the scale factor, the scale. It's very important that we differentiate, right? So the scale used to produce the diagram. And notice that I've been nice enough here to tell you, right, which one is which. You've got the diagram, you've got the actual, okay? So let's figure out the scale. I'm going to do that right here. And remember, because diagram and actual is being used, I'm going to stick to it. I know that. Ooh, my time. Okay, I want to finish this though. Diagram, actual. Okay. Do you know what corresponding sides means? Would that tell you anything? This side, right? This side corresponds to this one, correct? You would have to agree with me. Like this one corresponds to that one. So we're going to use these two to come up with our scale because we know them both. So we're going to go 14 inches to 25 feet. Is that allowed for scale? Can I have different units? Yep, you can. You can. Scale, yes. Scale is okay. So I'm going to leave it like that. You're done. Scale factor, right? Scale factor, not allowed. You cannot have decimals, guys. If this had been 1.4 and 2.5, what can we do to both sides to get rid of the decimal? Times 10 or times 100 sometimes, right? If they're two decimals, so make sure you understand that. I can't do every single scenario B. I will do it over here. Scale factor used. Scale factor to produce the diagram. So I'm going to go like this. The two sides that are known to me are already here. This is all connected, guys. Every single thing here is connected. Because I could have just looked at this here, at my scale, boom, come up with that. I happen to go back to the diagram and the actual here and just plug it in. I can't have that, right? No good. So I need to convert my feet to inches. That's what I'm going to do. Where should I do that? Over here. 25 feet, 1 foot has 12 inches. Cancel, cancel. 25 times 12. I don't think I have that over here. And I don't want to get this wrong. So it's 300 inches. So I'm going to go 14 inches over 300 inches. Cancel, cancel. And so I'm going to just put this on an aside here. And just leave it like that because you should know that. So K is 14 over 300. And you want to know a cool feature of this calculator? I love it. You will love it too. Ready? So go 14 divided by 300. And hit enter. So we're going to write that down. 0.0 0.05, right? Or 0.47. Let's go 3 decimals here. You multiply that by 100. I like to multiply what's on my screen. Oh, okay. We're going to leave it there. The homework is on the back side there, right there. I know you might be stuck on a few, but I think you have enough to get you going, okay?